Okay, how's it going, Mr. K? This is obviously my test physics problem, so let's see if this recording program works. It's been broken the past 5 times. A chain attached to a car applies a force of 6,000 newtons while pulling a 1,500 kilogram car up a hill that is 450 meters long. And this is obviously a 4-part problem coming from Physics Unit 7, Momentum and Conservation Momentum. Starting with number 1, how much work did the chain do on the car to pull it to the top of the hill? Like starting every question, let us list our knowns, which is force, mass, and distance. So now that we're trying to do work, what's the work formula? Looking at, if you have a formula sheet, it's work equals force times distance. And from here, it's as easy as just plugging in two variables. And you will plug in 6,000 newtons, 450 meters, and you'll get 2,700,000 joules as your work. Put a Harambe up here. Part 2. How much gravitational potential energy does the car have at the top of the hill? Okay, again, let's list our knowns. Now for our equation, we're trying to find GPE. So let's find our GPE equation. GPE equals mg delta h. Here it's as easy as plugging in variables, but we actually run into a problem. We don't know delta h and we don't know GPE, so we can't solve for two variables that we don't know. It's actually a lot simpler. GPE is actually equal to the amount of work done. So GPE equals work, and it's as simple as substituting. So GPE is equal to 2,700,000 joules as well. We'll put this up here. Part 3. What is the height of the first hill? Knowns. We list our knowns as always. We're trying to find a height, which is delta h, which luckily we already tried finding before here, but since we already found our GPE, we're only finding one variable now, which is a lot easier. So equation, GPE equals mg delta h, you plug in your variables, and just by doing the math, you will get h equals 183.67 meters, around, it's estimated. And for the final question, how fast is a car moving at the bottom of the hill? We list our knowns, like we always do. We're trying to find velocity here. So we're trying to find a velocity equation, but since it's moving, we know it's kinetic energy. So we do GPE equals KE final. KEF and GPE use the same exact formula, so we do 2,700,000 joules is equal to mv squared over 2. You plug those numbers in, you'll get v squared equals, you get v squared equals 36,000 or 3,600, and you'll get v is equal to 60 meters per second.